Hi everyone, here I am back again. So one thing I forgot to tell you about this figure-ground relationship that we talked about in class today is applying this to other senses. For example, we talked earlier about that cocktail party effect. So when you think about if you're at a party if there's a lot of people, or if you're in any situation, maybe even think about the college fair, if you were able to attend. The voice that you attend to in conversation is the figure, and everything else in the background is the ground. And then with that cocktail party effect, as soon as you hear your name, maybe from outside from the ground, then that new individual speaking would be the new figure. Reading and words, this is another example of figure-ground relationship. So on the page, the text that you're reading, the words is the figure and the white is the ground. And here are those Gestalt principles again. So take the opportunity to write them down. I uploaded 2 documents dealing with Gestalt psychology. One is simply these images and additional illusions that go along with that, and another is a website that describes illusions. It's really quite good. So take a look at that. And this concept that the whole is greater than the sum of the parts is the most important thing you need to understand with Gestalt psychologist. Think about love, and if you made me sit down and write all the feelings that encapsulate the feeling of love that I have for my kids, I could write and write and write and write, but even after I think I've written every possible detail I can, it's still not going to equal how I feel. And that's that concept that the whole is greater than the sum of the parts. So here's one illusion. It looks like these are connected. So you're using those principles of continuity. Wait a minute, what's going on here? And connectedness. But in reality, if we change, there we are. That's the actual doghouse. So there's that concept of closure. Our brains fill in the gaps. Let's see the previous image. We're filling in the gaps with our brain, assuming that there's closure. So then we have this principle of constancy. Objects change in our eyes constantly as we or they move, but we are able to maintain this content perception. So the door, it's changing, right? Its shape is changing, but we know it's still the same door. And there's size constancy. We see as something gets closer to us, it gets bigger, but we know it's still the same thing. We know that its size hasn't actually changed. And then there's the brightness constancy. So here we know it's the same object, but the light is making it look different. Here's some more examples, or a little more details with that. And then we have perceived motion. So it appears that this is moving, but it's really just each light is on a timer. The stroboscopic effect is a flip book. Maybe you made those when you were little. So that's the whole concept behind animation. If you move images that are still, but they change very, very little, if you move them quickly together, it appears as if they're in motion. And there's the autokinetic effect. If people stare at a white spotlight in a dark room, it appears to move.
What side do you want to go there?
Then we have depth cues. These are important. So there's an amazing experiment, just fascinating and very clever, done by a woman named Eleanor Gibson. She created this visual cliff experiment. So here's the apparatus. Let me back up. So how sad. She created this table, and this part is glass. So it appears like the kid's going to fall, but there's safety. The kid wouldn't really fall. And the child was placed here on this part of the table. And the researcher would be at one end of the table and say, here, come here, baby. And the question was, is that child going to fall off the cliff? Does that child have this concept of depth perception that, oh no, you better not go for it or you're going to fall? Well, it turns out that if you are old enough to crawl, you're old enough to see depth perception. What I love about this study is you still didn't answer the nature nurture question. Was a child born with this from the very beginning, or did the child learn from its environment that they need to perceive depth cues, or their safety would be damaged? So it turns out that by about 3 months, by the time the baby can crawl, they're able to do this. Now, there's some animals that can do this right away at birth. So from an evolutionary psychology point of view, it tells you that perhaps each species has been designed to have these depth cues at the appropriate time of development. And perhaps from a human baby's perspective, that infant has learned from its environment for those months of observing before that infant was mobile, that all of these depth cues are important for that baby or infant's survival. So there's 2 parts of depth cues. We have monocular cues and binocular cues. Mono 1, bi 2. So pay attention, there's 5 of these you need to know. And the concept here, you really actually only need one eye to use these cues. So we have linear perspective. Notice how we know, because of the way these lines are arranged, that this is showing us distance. Parallel lines look like they're converging over a distance. Then we have interposition. So if something is blocking something else, the thing being blocked is farther away. Yeah. Right? We know that this one's in front and this one's behind. We don't think like, oh, that's kind of a really weird car that is shaped funny. We don't think that way. Then we have relative size. So we know that this individual is smaller than this individual. They appear smaller, yet for our perception, they're the same size. They're humans. Then we have texture gradient, and objects look smoother if they're farther away and rougher if they're closer. So we don't actually like those close-up pictures of celebrities or anyone because they look much more rough. You can see the crevices, the bumps, the imperfections all over. Yuck. And then finally we have shadowing. So you know that even if an individual is in a shadow, this is a weird picture, but the point here is if an individual is in a shadow and the light is different, our eyes and our cues allow us to perceive that, yeah, it's in a shadow, but it's still the same object. Now what about this one? What do you think? This is the St. Louis Arch. Is the arch taller or is it wider? Well, most of us assume that it's taller than it is wide, but actually it's the same, it's equal. Why is that? Well, our eyes tend to perceive vertical as taller than the identical horizontal dimensions. Then we have binocular cues. So these are more depth cues. And this concept is we need both of our eyes for these kinds of cues. So first we have retinal disparity. So as the object comes closer to us, the differences in images between our eyes becomes greater. Try this little finger sausage real quick. Take your 2 fingers and put them pointing at each other, so parallel, I guess, to the ground, and about 5 inches in front of your eyes, and put the tips together about a ½ inch apart. Take a look at it. Stare at your fingers. What do you see? And then move your fingers back and forth. You should see at some point this weird finger sausage, like you see the fingernails of both fingers, yet they're attached on the other side. That's an example of retinal disparity. Then there's convergence. As an object comes closer to our eye, our eyes have to come together to focus on the object. So think of like how your eyes could become crossed if you're staring at your nose. Nice. Here's another one. Which one do you think is longer? Many of us in Western cultures think that this one is longer, but actually if other people in other cultures are asked this question, a culture that maybe doesn't use right angles, so a culture that isn't maybe as carpentered or as manufactured as a Western culture, individuals aren't fooled by this illusion. Individuals in other cultures say, oh, they're the same, but when I'm looking at this looks so much bigger than that. So if you want, print off the slide, measure it, take a look. They're exactly the same. Here's another illusion with the moon. The question is, why does the moon always look huge when it's on the horizon and tiny up in the sky? So this goes back to our size constancy. So we perceive this as bigger because in our minds we think it's the same distance from where we're standing to the moon over the horizon as it is from the moon up in the sky. Yet, in fact, that's a perception. And there's that fleeing monster image again. So if you measure this, this is cut off, so make sure you print off the slide and you measure this one. They are exactly the same, yet this one looks so much smaller to me. And here's a famous illusion, the Ponzo illusion. Again, looking at this, this one looks way bigger than this to me, yet they are exactly the same. Then there's lightness constancy. Which of these inner squares looks lighter, which darker? Well, in reality, they're exactly the same. We perceive an object as having a constant lightness even while its illumination varies. And then here's an example of an illusory depth. So we're play on that depth perception. And there's that image, the man playing the saxophone again. Yes, it's a saxophone. And what you see is really influenced by your perceptual set. Sorry, that slide is cut out. So we have this concept called perceptual set. So remember, that is like that top-down processing. If I give you something, if I had shown you this image before showing you this one, you would see the saxophone player. If I had shown you this image before showing you this one, you would have seen the woman first. That's a perceptual set. And just two little slides here from your textbook. We have perception and the human factor. So there's this whole area of psychology called human factor psychology that explores this interaction between people and machines. The best example is when we had the iPod iNeuron game that you played. There was a human factor psychologist who worked on that team, exploring that interaction between the relationship between the student playing that game and the machine, designing the iPod and designing the application for humans. And then finally, there's that ESP question. So here's the answer. Some schools do have this parapsychology area. Very few. I think there's like 4 in the entire world. None in the U.S. as far as I know. So there's the claims. Nothing. It's been unable to be proven. And that's it. Have a great weekend, you guys. I'll send a text with the information that I've uploaded that I'd like you to check out. And make sure you study. 25 to 30 question quiz on Monday.